Residuals. Residuals are the difference between the observed and the expected values as modeled in the line equation. So we can think about it as the data equals the fit plus the residuals. And the fit is the linear equation. So in the example here of possums, these are each dot or each circle is a data point, and the distance, if we're talking about visually geometric, or the difference, we can also compute it algebraically in our equation, is the distance or the difference between the point itself of the data and the estimation of the line, also called the fit. And there's a neat kind of explanation here on the from the textbook. So the residuals, the difference between the observed and the expected values. The expected is the one modeled, and the observed is the actual observation of the data. So the residual of the ith observation, when we notice this ith, notice that since we have multiple instances, right, each circle is an instance. In this case, it's a possum. The ith means that any one observation. So maybe we have the first, the second, the third, the fourth, the fifth. The ith is any one specific. So this is the common notation we use. So it's just referring to the one specific point. Is the difference of the observed response and the response we would predict based on the model fit. So the actual y value versus the estimated y value. And the residual is the difference between those two, the estimated from the actual. We typically identify y hat, yi by plugging xi into the model, right? So let's do it over here. Let's see how it works. So suppose we have the this point over here. Let's focus on this red one, and it's about the total length is about 76. Okay, so we have a possum with a total length 76. So what's the estimate? Let's put a y hat here. So the y hat estimate equals 43 plus 0.57 times this x is the number, so times the x times 76, which equals 86.3 millimeters. The y is in millimeters. So if you told me you found a possum and it had 76 centimeters, the linear model, the fit, the equation would estimate that its head would be 86.3 millimeters. But in this case, it's actually not 86.3 millimeters, it's 85 for this one specific case that we found, that was indeed 76. So what is the error? What is the residual? Well, the error is just the difference between what we estimated, 86.3, minus the actual observed value of the data that we have, which is here is 85. So 1.2 millimeter is the residual for this specific point, for this specific observation. And you can say, okay, that's small, that's big. It definitely seems smaller than some other ones here, right? This distance is bigger than this distance, and this distance over here is bigger than this distance, and so on. So the residual is this difference, and we also call it the error term. And what we can do is actually we can sum all of the differences between each point and the line. So we can get an estimate of the total residual or the total error. So the key idea here is that we want to pick a line that minimizes the residuals, right? Because if we put a line here that has a lot of error, has a lot of difference between the line and the points, it's not really going to be a trend line, right? So imagine we actually draw a line like this. Well, maybe kind of gets to the trend, but this line is not very good because the residuals are going to be very high because all the actual data points are very far from the line. So how do we know that this line right here is the perfect one and not maybe one over here? or another one over here. Well, that's the job for least squares regression, which we'll talk about later. So now we will go on to correlation.